Here I come, ball. Darn it. I hate this game. This is so stupid.
Whoa.
I hate this game. I got a 35 and it's only a par 3.
Someone got to teach you how to play golf. It's all in the laws of physics. Don't you know that?
Physics?
Yeah.
I took that course. It was the best opportunity to do American Studies homework.
Watch. Let me show you how it's done.
You're so great. Go right ahead.
See, look at that. It's all in the laws of physics.
So, that was pretty cool how you bumped it off these bricks and stuff. How do you do that?
The law of reflection states that the angle of reflection equals the angle of incidence relative to the normal. This is always true for light, and it works for particles too. So knowing that, we can know what angle to hit the ball at the wall with so that we'll get a hole-in-one.
No kidding. Ay caramba, I don't believe you. Show me how it works.
Watch me hit the ball at the right angle at the wall so that the ball bounces off at the same angle that it hit the wall at and goes straight into the hole.
I'm gonna get a hole-in-one this time. I know it. Yes! Yes, I got a hole-in-one! Woo! I'm Tiger Woods. Well, without that baggage.
Newton's third law. Every action has an equal and opposite reaction.
Whoa, that was really cool. I can't believe I got a hole-in-one. Yes!
I know.
That's 34 points less than last time. It's pretty cool how the ball reflects off those bricks.
Yeah, you're finally starting to get the hang of the physics.
Oh, that's pretty interesting stuff.
Or at least one part of physics. There's so many more parts of physics that we haven't even begun to discuss. Take Newton's third law, for example. Newton's third law.
What is that?
Newton's third law states that when you hit the ball off the wall, the force that you hit the ball with is the same force that the wall's going to push the ball back off the wall with once you hit it.
Ay caramba!
That's what she said.
You wish. So if I hit the ball against that wall, it will bounce off with equal force?
You got it.
I don't believe you. What a load of... But how come it goes slower?
Because once you hit the ball off the wall, it loses some of that force due to friction.
And something about heat energy, right?
Right. There's heat energy, there's sound. When the ball hits the wall and comes in contact with the wall, the frictional force that's active upon it releases some heat and also some sound. That's why you hear that noise every time. And some force is lost due to that, which in turn slows the ball down.
You know, that does ring a bell. I think I remember Miss Finley talking about that while I was reading about Abraham Lincoln.
So you did pay attention to physics. Buoyant force. The force exerted upward on an object by the liquid in which it is displaced.
After that first hole-in-one, I'm gonna get another one. Hiya! Okay, good thing I got another ball. Hey, how come this one floats a lot more and that one sinks a lot more? You're playing a trick on me.
Because there's a buoyant force in each ball. The buoyant force is the density of the liquid displaced times the volume of the liquid displaced times the acceleration due to gravity. An object whose weight is greater than the buoyant force will sink, while an object whose weight is less than the buoyant force floats. Both balls float, but the orange one almost sinks, which means that its weight is almost equal to the magnitude of the buoyant force.
That's a huge hill. How the heck am I supposed to make it up there?
Well, you have to give the ball enough energy when you hit it to make it up that hill.
And how do I do that?
You put a little more oomph in your swing.
Huh, interesting. With enough energy to make it all the way up there?
Right, you gotta hit it hard enough to overcome the loss of heat, friction, and sound as the ball's rolling up the hill.
Huh, interesting.
Try it.
Okay.
See how hard you can hit the ball.
Ah!
Nice. Mini golf has a lot to do with energy. The potential energy stored in the club is given by the mass of the club times the acceleration due to gravity times the displacement of the club due to the ground. The potential energy of the club and the energy of the swing you give the club is converted into kinetic energy as the club strikes the ball. The kinetic energy is given by 1/2 times the mass of the ball times the velocity of the ball squared. The amount of energy given to the ball determines how far the ball will travel. The ball must overcome the work done by the frictional force.
Oh no! I think I used too much energy.
That's what it looks like.
Oh, it.
Did I tell you not that much oomph? Now watch the pro.
Ooh.
Yeah!
I never knew there was so much physics in mini-golf.
Yeah, there is. You would know that too if you ever pay attention to Mrs. Finley. Miss Finley knows all.
Law of reflection, Newton's third law, energy, and all
Buoyancy?
that. Hogwash buoyancy.
There we go.
Well, if you play mini-golf right, you're not supposed to know about buoyancy.
Oh, but we learned all about buoyancy, didn't we?
Unfortunately.
Hit the ball into the water almost every hole.
Watch it, mister. I can't believe it. The physics has helped me out so much. I've been doing so good in this game. This is the first time that I don't need my TI-84 Silver Edition to add up my score.
Pretty impressive.
Well, we'll see how much that helped me. All I know is I better not get a 35 on this hole.